Hi. Okay, so today we're going to talk about one of our practicals, which I thought everyone had a problem with. Okay, so these practicals come from page 2008. It's a question paper 3-1, and let's say the summary of the question is really simple. What you have is a monoprotic or monobasic acid, and you are to determine the relative molecular mass of the acid and deduce its molecular formula. You are given the density of the acid, and you are also given the density of NaOH. Now, you need to use a certain amount of Fa1, which is the aqueous acid, and place those into a 250 centimeter cube graduated flask. Then we need to dilute this certain amount. So we have V1, and this is of acid, and it should be around 38 or 39 based on what everyone here is saying, based on the paper. And you'll end up with V2, which is 250. So first we diluted, and this was our first mission. Then what we did was we wanted to mix everything so well, and we wanted to titrate. So we wanted to titrate the diluted solution into using NaOH. What we did was pipette 25 centimeter cube of the solution that we diluted, and then we had a few drops of phenolphthalein, and we titrated using sodium hydroxide until this becomes colorless. Okay, now this is not the problem because the procedure was really simple. What happened was the application of the procedure was not exactly the way that I wanted it to be. Okay, so let's look at the questions that followed. Okay, so what we have is the questions that we need to solve for, okay? So let me see. Okay, so what we need to do is we need first to create a table for our titration values. Then we need to show our titration values so correctly, and this is what we are doing in part A of the question. In part B, we need to obtain the volume of Fe3 that was used in our calculation and to show how we can obtain this volume. Now, because we have already done a few titrations, we might do one accurate titration where we are certain about the accuracy, or more than one titration and we get the average, okay? Now, the average needs to be calculated to do decimal points, and you need to also be sure about your significant figures, okay? Now for the next question is, we have calculate how many moles of NaOH has been pipetted into our conical flask. Now for this one, you only need to know the amount of moles that were pipetted. So let's look at how to do that. We have 20, for example, if we have 25 milliliters, we already have the density, and we can get the number of grams of NaOH, and then we can get the number of moles. I don't think that anybody has any problem with that, okay? Okay, now for step 2, which is this one. Use the volume in B and the answer above to calculate how many moles of RCOH, which are contained in 250 centimeter cube of the diluted acid. Now let's look at the experiment, what we did. First, we did the dilution. Okay, this is a very bad handwriting. What we did was, and this is somewhat our volumetric flask, was fill out a volumetric flask of a certain amount of RCOH, and then we filled it with water. So we've diluted this volume. Then what we did was do a titration. Okay, so for our titration, what we have done is basically take out small volume of the diluted solution and we placed it and we titrated with a 250 with 25 milliliter. Is that true? Yes, 25 milliliter of NaOH. Now for titration we remember that it was all about stoichiometry. So let's write the equation for this one. It would be RCOH plus NaOH, which is an acid-base reaction. Remember that acid-base reactions always give H2O, so you have one H from here and one OH from here. So we would end up with RCO2Na plus H2O. And this is a balanced equation. What we notice here is that our stoichiometry is 1 to 1. So we can find out the amount of mole that we use during titration based on the stoichiometry. Okay, great. So we can say that for 1 mole RCO2H, we will have 1 mole NaOH. So remember that in the previous question we had a number of moles, okay? Now, for this number of moles, let me calculate mine. So let's say that you have 0.02 moles. Okay, wait a minute. Let's say that you have 0.085 moles of, you should get something like this, like 0.085 moles in NaOH. Then you would have X and you can cross multiply. Okay, great. Now we found out how many moles we have. But this is not the moles in the entire 250 flask. These moles are only the moles used in the reaction. So we only found out the number of moles in a small amount. Let's say that we used around 28 centimeter cube. This is the only moles found in the 28 centimeter cube of RCOH. What we want to find out is the moles in the 250 centimeter cube, not in just the small amount that we reacted. In order to do that, we can look at the way things are diluted. When we dilute something, we keep the moles constant because we're not adding any more of it. If you have, for example, a very concentrated tea with a lot of sugar, you might want to add some water to dilute. You haven't removed the sugar or the tea, you're just adding more water. So the same principle applies here. The number of moles that were in the 250 centimeter flask should equal the number of moles in the initial solution, which is great. But what about the number of moles in the 250 flask to begin with? Okay, here you just do a cross multiplication. So we found out that 0.085 moles RCO2H from stoichiometry is in 38 centimeter cube. What about the 250 centimeter cube? We just do a cross multiplication. Okay, great. Now, for our last question, we need to show that we understand the amount of material that is being diluted. So let's see. So we want to find out the amount of moles in the undiluted acid. Again, if we look at the dilution process, it's just the addition of water. And in the previous example, we just cross-multiplied. So we found out the amount of moles in the 250 centimeter cube. Now the amount of moles is equal before and after dilution. Before dilution, we have C1V1, and after dilution, we have C2V2. Now, what we want to find out is the concentration in the initial volume. So we want to find this value, the C2. We only divide by V2 and get this. Now, V2, V1 seems a lot to understand, but this is basically what happens. What we are saying is that the concentration in the 250 centimeter flask times 250 over 1,000, I just divided by 1,000 to get the decimeter cube, should be equal to the concentration in the initial volume, which was 39 centimeter cube. Remember that this is the FA1 times 39 centimeter cube over 1,000 to get decimeter cube. Okay? So our new concentration should be calculated this way. So we know the concentration of this. Okay, great. But why do we need it? We need it to find out the relative molecular mass of our lovely solution. So let's see how that works. Now, we were given the density in our equation. We found out the concentration. How do they relate? Now, density has a gram per decimeter cube units. Our concentration, our concentration has mole per decimeter cube unit. What we want to find out is the MR of solution. And this is gram per decimeter cube over mole per decimeter cube. These two will go away and you would end up with gram per mole. So now that you found out the concentration of the initial solution and you have the density of the initial solution, you can find the MR of whatever material you have. And this is a monoprotic acid. Now, after you find out the MR, you need to just check how they weigh together. So you just need to know how they weigh, right? So we have RCOOH. Whatever value we have should determine what R is. Remember that R is a hydrocarbon chain, so it's CH3, CH2, CH something. So it's definitely made only of carbon and the hydrogen. And that's how we get our question. Thank you so much.